Welcome all on the video tutorial on machine learning, and we'll discuss about the last topic of our third module, which is backpropagation. What is backpropagation? When do we go for a backpropagation? So usually our mechanism, what we follow in artificial neural network, is feed forward mechanism. Okay, the input will be given to the input layer, that will be processed to your hidden layer, and from the hidden layer the output will be given to the output layer. This is the usual mechanism that is followed in an artificial neural network. But when we don't get the expected output, when a given set of input, when we don't get the expected output, then we come to the conclusion there is an error over the network. So you would have already trained the machine for this inputs. This is the corresponding output we are supposed to obtain, and only with this learning mechanism, whenever an input is given, it is going to predict. But when you don't obtain the expected output, what it implies? It implies there is an error over the system. In that case, we back propagate. Okay, usually we follow feed forward mechanism, but when we don't get the expected output, we back propagate. We change the weights, and we then continue with our convolution function. See here, why do we go for backpropagation is depicted in this picture. We have an input layer, and we have an hidden layer, and we have an output. So we know how a convolution function is carried out in the input layer. We'll be multiplying the input with the weight, and we'll be adding the common bias to that. So the output of that hidden layer will be given to the output layer. Now you get an output, and that whether that, and we go with a prediction. So we would have already trained the machine for a given sort of input, what is the prediction it has to obtain. But when it does not obtain the expected output, it is back propagating. It is again propagating back to the hidden layer, and here again it propagates back to your input layer, and it is going to change the weights. For the first set of data, for I1, when you assign weight W1, you are not able to get the predicted output. Now what you do, you are going to alter the weight, and again you convolute, so that the output what you obtain will be your expected output. Okay, they are given one example here. See, I1 is your input, I1 and I2 is the input values, and it has the weights 0.11 and 0.21 for the input I1, and it has the weights I2. For the I2, it has weights 0.12 and 0.08. Okay, now what happens? The convolution starts with the first weight. First I multiply I1 with 0.11, and I'm going to add the common bias there, and I get an output there. And that output I'm going to again multiply with 0.14, and I get an output. When I don't get an expected output here, I'm going to back propagate. Now what I do, I am going to try with the other weight. So first I have tried with the input I1 with the weight of 0.11, but I don't get the expected output. So now what I do, I am going to try with the other sort of weight. I may try with 0.21, or I may try with 0.12, so that the error what I get is minimized, and my prediction may be accurate. And now when do you go for backpropagation? Whenever you analyze there is an error in the mechanism, when there is an error in the output. So what is the first step here? You have to calculate what is the first step to decide whether we are supposed to go for backpropagation. It is first to find the error. How do you find the error? We will be finding the error using the formula 1 by 2 multiplied with the predicted value minus the actual value, the whole square. Okay, what is this? Whenever you don't get an output with expected output, then you find that there is an error over the system. Okay, so now what is the step? You are supposed to calculate the error value. How do you calculate the error value? You will be subtracting the obtained value with the expected value, and you get a square value of it, and you divide that by 2. When you divide that by 2, you get the error value. With this error value, you apply this in a mathematical function, and you back propagate it. See, you have an input 0.23, and you have the weights for that as 0.11, 0.21 and 0.12 and 0.08, and after convoluting you get 0.85 and 0.4, right? And for the corresponding weight for that is 0.14 and 0.15, and the output what you obtain is 0.191. Okay, but what is our actual output? We are supposed to get 0.10 as our output, but we don't get that output. Okay, now what you are going to do, we are calculating the error. How do you calculate the error? Predicted value minus your actual output. What is the predicted output I have obtained here? I have obtained 0.191. So I am going to subtract that with the actual expected output, that is 1.0. So when I get the error value 0.327. Okay, this is how you calculate. Now you find out an error and you will be back propagating. So now next we'll see the topic of gradient descent. What is this gradient descent is? Whenever you find there is an error, we go for a back propagation. What we do in back propagation? We are going to adjust the weight. Since the previous steps, the previous way of calculating your output, it doesn't yield you the expected output with the corresponding weight. So now what we are going to do is, we are going to update the weight. The updation of weight is done by the gradient function. Okay, what is the use of gradient descent function? Whenever you have a back propagation, you are going to update the weight, and this updation of weight is done by the gradient descent. What a gradient descent does here, it is going to find the minimum function, it is going to find the weight, so that it is going to give you the minimum error. When your error is minimum, your prediction will be accurate. So you have a graph depicting the gradient descent function. So whenever you have an error, it indicates that you are supposed to go with back propagation. Now you are supposed to increase your weight or decrease your weight to obtain your global loss function. Okay, to reduce your minimum error, either you are supposed to increase your weight and or you may decrease your weight, and this gradient descent function decides over it whether to increase your weight or decrease your weight. See, this is the model for an back propagation. Okay, whenever you give an input in the model, we are calculating the error, and if the error is minimum, there is no issue. You have an approximate prediction. Your model is ready for prediction. Or if you have maximum error, if your error value is more, it specifies that you need to back propagate. And how do you perform the back propagate? You will be updating the parameters. Okay, when it is minimum error, it goes for prediction. When the error is maximum, it goes for updating the parameters. And what is the parameter updated here? We are going to update the weights. Initially, for the given input set, we have convoluted with the weight assigned to it, but we don't get the expected output. Since we don't get the expected output, we are going to try with different combinations of the weights. That is what updating the parameter. How this updation is done? This updation is done by the gradient descent function. Only that gradient descent function decides whether to increase the weight or decrease the weight, so that you obtain an minimum error. This is the overview of an